Today we're going to talk about infrared, and we want to talk about evaluating a hotspot or evaluating a problem, a write-up that comes in your infrared inspection. You know, a lot of times people just think because they say infrared that everything must be about the temperature. And I tell people temperature is just one component of it. If it was just temperature, then anybody could just buy a camera and point it at an object and say, hey, that's got temperature, it's got high temperature, we got to do something about it. But when you look at the infrared inspection, you look at the process, it is both a quantitative and a qualitative approach when it comes to evaluating the problem or the recommendation. One is based more on hard facts. So a hard fact would be, hey, this is 28C, I got heat on this lug. Or a hard fact could be, hey, I'm running at 12 amp load on there. But you know, there's also a subjective, an objective side to it that evaluates it from experience, from observation, what you're looking at, understand the system as a whole. And today that's what I want to do. I want to take a few minutes and just walk you through that when you're evaluating a write-up, a hotspot, that there really should be a 5-step approach to that process. The first point, which makes sense, is temperature. I mean, we're talking infrared, right? Temperature plays a big factor because it's the temperature or lack of temperature sometimes that identifies the problem first from the person doing the inspection. Now, the temperature should tell you, is it a connection problem, an internal problem, a load problem? The temperature will let you also know, if it's so high that it might be a greater severity than something that's a lot lower, which can be the case and not be the case. But your temperature will always identify first the problem that makes you do the additional investigation that's on there. Factors that should be included in is wondering what type of load it's on there. It could be if it's running a fair amount of load, that's why the temperature is high. It also could be if I'm in a warmer ambient temperature in the room, say the room's 80, 90, 100 degrees, my temperatures might show a little bit higher. But also I got to realize that if I'm in a colder room, like I've been in freezers for meat packing companies, you know, they're 12 degrees. You know, I might be looking for temperatures that are down 12 degrees and there. So the ambient temperature, the room temperature all affect that. But when you're starting the process, you got to take all that stuff in consideration when you're looking at what is the actual temperature that's identifying the problem that I'm evaluating. Now, your second step is amps. You know, checking the amperage, the running load. You know, we talked about that. That could affect the temperature. But you need to know what the amp load is, because sometimes I think we identify things like, oh, there's heat on there, but that might just be what we call normal running temperature load. You know, I can have a 20 amp breaker that could be running 14 amps on say it's a lighting circuit. I know it's running for 10 or 12 hours for the day. You know, acceptable temperature might be 38C, 39C. So we have to use amperage to identify that is my temperature I'm looking at load based. I might have a lot of heat on something and say, wow, I wonder if this breaker is really bad. Well, it might be running hundreds of amps. So as I have more amperage, I have more heat. As I bring down amperage, I should have less heat. So amperage does play a big part in evaluating, is this heat legitimate? Is it normal running? Or is it telling me that I've got a problem here, like an overload or possibly a non-load issue? All right, our third step is what we call millivolt drop. And to keep it simple, it's using a multimeter. You know, we use a multimeter a lot of times to check voltage, maybe of equipment running to see if something's still powered up. But you can use that same multimeter and look for loss of voltage through 2 points of connection on the same phase. So say you had a breaker. Say I was scanning a breaker and I noticed it had 8 amps on it, but it was like 50 degrees C. Well, I would use my multimeter to check, you know, what kind of resistance I had on there. So maybe the normal resistance might be in the 30s or 40, what they call millivolts. But if I started getting 100, 200, 300, what that millivolt drop will do will help me to validate that, hey, I saw heat inside the breaker, and I'm using that to verify that it is the breaker. I also can use that same meter and say, is it the breaker or is it the connection? Because if it's really the connection, why do I need you to change the breaker? So a millivolt drop is a great tool to use to help evaluate the source, where the problem really is, and actually give you a hard number to say, yes, I'm saying it's the breaker, and here is the millivolt drop reading for it. Now these last 2 points are, to me, is really where experience comes in. Because this is where you start to see the system as a whole and realize the importance of what I've looked at for amps, temperature, and millivolt drop. How does that relate to what I'm looking at that's in the electrical system? So step 4 is what I call the criticality of the piece of equipment. So when I have a hot spot, I want to know what it feeds. How critical is that piece of equipment? Why is that important? That'll help me prioritize how quickly you should respond to that problem. You know, if it's my main breaker, it's my main switch, how critical is that to the operation of the building? If I have one supply fan for the building, you know, and I've got a pretty good hot spot on something, how much of attention should I give to that more immediate, or should I kind of put it off? See, when you look at the criticality of a piece of equipment, you want to say this: if I ignored this problem, what effect would it have on my system if it failed, if that breaker tripped, if I lost a fuse, if I lost that motor? What does it affect? That should be definitely part of the evaluation, because it should tell you, is this something I should fix in the next few weeks, in the next month, or can I put it off a little bit? So criticality of a piece of equipment needs to be a key component as part of the evaluation. Our last step, but not our least step, is what I call step 5, physically damaged. You know, sometimes you'll come across stuff that you'll visually catch. Sometimes you catch it in the camera, and it'll be burnt. It'll be actually broken. It could actually weld it itself, but only show maybe a degree differential. You know, very low temperature that's easy to blow off. But when you're evaluating, and you have to see not only amps, not only millivolt drops, not only temperature, not only criticality of piece of equipment, but is it physically damaged? Because I know if I look at it and it's already burnt itself, I don't know how many times it's gone through that cycle. How many times has it heated up to a couple hundred degrees, welded itself, burnt itself, and now it's cooled back down. Now it's a dirtier connection that's a little bit more fragile. I don't know where it's at in that cycle since the last scan. So when you're looking at the problem, you want to see, hey, is it physically damaged? And when you see something physically damaged, there's more of immediate attention needs to put on it. It doesn't matter if it's a small little 20 amp breaker or if it's the main for your building. Either way, we know that component has the potential to fail a lot quicker because it's already started that process. So when next time you're having an inspection done and someone's going through looking at your building, these are really the 5 components they need to think about. Make sure that they're evaluating not only the temperature, but the amps, the millivolt drops, the criticality of the piece of equipment, and also is it physically damaged. When those 5 steps are used in the approach and they look at your system as a whole, it'll give you better guideline of how you should address the problems in your report and then the time frame you should address each one.